Hi everyone. So we're going to talk a little bit now about climate tipping points. So I guess the first thing is to understand what is a climate tipping point. So it doesn't mean that we're going to be tipped into an apocalyptic scenario from one moment to the next. So we can consider it like a seesaw, like we can see in this kind of video above. So we can see the Earth kind of rose up very, very slowly along the plank. So this is our climate changing and our temperature rising slowly, slowly at first until it reaches a climate tipping point, which is here at the middle of the seesaw. And at that point, it begins to roll downhill and it's at a kind of irreversible and unstoppable point. So again, it's not an immediate catastrophic event. However, once it reaches the middle or the climate tipping point, as we can call it too, it can't be turned back. And you can learn a little bit more about climate tipping points at that website below, climatetippingpoints.info. So I guess just to talk about the degrees of warming. So you may have heard that more than 2 degrees of warming is already locked in, meaning it is unavoidable. And even NASA maintained that this is a fact up until recently. But recent research has established that this isn't quite true. So if we stopped all emissions, including methane emissions now, there would be an overall cooling by the year 2100. Therefore, it is more apparent than ever that we need to act immediately. And unfortunately, as you saw in previous slides, governments are still not doing enough. And the national determined contributions, especially the ones committed to by developed countries, are not enough to stop us heating to at least 2 degrees Celsius. So there is an urgency for action like we have never seen before. So to give an example, I guess, of a carbon tipping point, we can look at our world oceans. So as you know, our world oceans have a huge amount of area and a huge amount of volume, and they provide us with a really important service, which is storing carbon. So you can see there, atmospheric carbon can be dissolved into our waters, and then this can be stored as carbon in the deep, cold waters. But the problem is that as our ocean temperatures are warming, this prevents the ocean from storing all that carbon. So the warmer the water temperatures are, the less carbon that can be stored. So let's say our atmosphere is now has more carbon, which means there's higher temperatures, which means our water is warmer, which means that less carbon can be stored deep in the ocean. And this carbon is being released into the atmosphere, which makes the temperatures warmer, which makes the water warmer, which prevents us from storing more carbon dioxide. And that loop continues on again and again after it reaches that climate tipping point. So this is kind of known as a positive feedback loop, which in this case is not positive at all. But that's an example of a climate tipping point. So I'll leave you now with this video. So it's a quick recap on what is a climate tipping point. It gives some more examples of climate tipping points, such as ice sheet melt. So you can find that just by typing that title into YouTube.
Climate tipping points are a growing concern for both scientists and the public. But what are they? How might they affect us? And can we predict them? The Earth's climate is changing, with humanity's carbon dioxide emissions pushing up average temperatures through the greenhouse effect. So far, temperatures have gone up steadily along with CO2 emissions, but future warming may not be gradual. Passing a tipping point can cause rapid change. You can think of tipping points like a seesaw. Pushing the ball up the ramp is like human CO2 emissions pushing temperatures up. Before the pivot is reached, the ball can come back down, but once you pass the tipping point, the ball carries on and speeds up without any further pushing. Eventually, the ball comes to rest in a new steady state, and it is more difficult for it to return. For the climate, this would be the Earth passing a climate tipping point and reaching a new normal as a hotter planet. Tipping points can happen when positive feedback loops kick in. One of these may now be happening with Arctic summer sea ice. Sea ice reflects more energy from the sun back into space than darker open sea, and this keeps the Arctic cooler. But global warming is melting the summer sea ice, which is exposing more open sea, reducing the solar energy reflected by ice, and amplifying local warming. Beyond a future tipping point, the summer sea ice may rapidly retreat and the whole Arctic will warm up much more than the rest of the world. This feedback loop has already started in the Arctic, and there are many other potential feedback loops linked to climate change. Other possible tipping points that may soon be crossed include ice sheet collapse in West Antarctica, which would raise sea levels, and methane release from melting Arctic permafrost, which is a strong greenhouse gas would amplify global warming. We want to be able to predict tipping points like these in advance, so that we can either avoid triggering them or prepare for the consequences if that's too late. Scientists are using models and records of ancient climate change to find when tipping points may have happened in the past. One example is when ice sheets rapidly melted at the end of the Ice Age glacial periods, despite having been stable for tens of thousands of years. Before these ancient tipping points, subtle changes like increased variability can often be seen, which are known as early warning signals. These are a bit like when a spinning top slows down. It starts to wobble more and more before it finally tips over. We can monitor the climate for wobbles like these using advanced mathematical techniques and then compare them to records of ancient climate tipping points. To find out more about climate tipping points, visit www.climatetippingpoints.info, follow Climate Tip Point on Twitter, or find climatetippingpoints.info on Facebook.